And from there you can end up with that. And your theta is going to be this. Now, guys, theta could be always in degrees or in radians. We can do either one of those, okay? You've always seen it more likely in degrees. And when we get in more into this stuff, you're going to start seeing that we go back and forth with the degrees and radians, okay? So it goes, yep. That's okay.
Will initial always be at the bottom and terminal always be on top?
No, because sometimes you could have, and I didn't see, there's this one here. We could start here. This could be your initial. And you can go downwards. And that could be your terminal. So you could go also clockwise and stop from there. This one went all the way around, but initially the idea is, and I hate the word use initial for a better term, but initial will always be your positive x-axis, is where you usually always start. So it says angles must be positive or negative. Well, positive angles rotate counterclockwise. And then negative angles are clockwise. So if you see the rotation we did here initially, this is a positive angle. Actually, you know what? Let me do it this way. Positive theta. Let's do a different color. Positive theta. Over here, we went clockwise with this, so this is going to be a negative theta. Here we went counterclockwise, so we start with the x-axis and went up and around, and so that ends up being a positive theta. And then finally, the last example I showed you guys ends up being negative. So it's depending on where you're going around the circle if it's going to be positive or negative. And let's talk about one thing that's going to be really, really important when we talk about pre-cal, big time when we're doing unit circle stuff. Reference angle. Reference angle has a few things you got to think about. It is an acute angle to the x-axis. Always the acute angle to the x-axis. One more thing. Always positive. So when you see something like this, okay, you say, all right, it's here is our angle we're looking at, which means we started here and we went around to there. Our reference angle, guys, what we're going to reference this to is going to be the distance from here. It's the angle from there to there. It is always going to be an acute angle down or up, you'll see another example, to the x-axis. Now, when the angle is in this area right here, it's pretty simple because what's the definition of an acute angle, guys? Smaller than 90. What's the degree from here going up to there? How many degrees did I just go? 90. So everything in here is real straightforward with reference. If I went up 45 degrees and I'm here, the reference angle is 45 degrees. However, if I go here and go into the what's called the second quadrant, first quadrant, second, third, fourth, if I go into the second quadrant right here, guys, let's say I'm going 135 degrees. 135 degrees takes me past 90, and how much more? 45 more. So let me ask you this, guys. What's the number of degrees to get me down to the x-axis? 45. So 45 is your reference. It's always the angle either up or down to your x-axis, okay? So then we go ahead and look at another example, which would mean, okay, what if we were to look at something here? Well, if you look here on this one, this would be your reference angle. It's where it goes up to the x-axis. Still acute. You're always in that quadrant. You're staying within that quadrant, guys. And so what you notice here is, okay, 90, 180. Let's say I go over to 225. I'm at 225 degrees. What's the reference angle? How many degrees would it take me to get back to 180?
What'd you say again?
If I went 225 degrees to stop right there, how many more degrees do I need to go back up to get back to 180 that I've already passed?
45.
45. So your reference angle is 45 degrees. Notice when I say reference, it's always going to be that acute angle, and it's always going to be the angle back to the x-axis. Okay? Sometimes it looks interesting because you have something like this. And this is a rare case, guys. It does happen, but it's rare. But we got to talk about it. What if it lies on the axis itself? What if it lies on the axis? Then your reference angle is 90 degrees. Okay? Your reference angle is 90 degrees. So you got it where, okay, what if it's in the top half? Well, you're going down to the x-axis. What if it's in the bottom half? Well, you're going up to the x-axis. And then finally, what does it lies on it? Well, you got a few options here. That's going to be 90 degrees. Guys, what do y'all think this one's going to be here? I shouldn't have wrote that color. But you get the idea. What should it be, guys? Zero. That's exactly right. So this is 90. This is 0. This one we had an example, whatever. I'm not going to label that, but you get the idea. When you're labeled, when you stop on the x-axis, it's 0. When you're on the y-axis, it's always 90. And then anything else in between is in between those, okay? Sorry I crammed that in a little spot there. Not the best spot, but I hope you got those written down somewhere. All right, reference angles, guys. It's pretty much a foundation of what we'll be doing for the next couple weeks. We don't have long because we have the Christmas break coming around the corner, so tell me about it. All right, so then we go ahead and talk about coterminal angles. Coterminal, they have the same initial and terminal sides. So if you look here, guys, at this one, it started here, and there's one way to get there. That's one way to get there. This is going to be our positive angle. So it's a positive angle. We could also, guys, do another direction. We could go in a negative direction and still get to the same point. After all, we are talking about going in circles, right? I think you guys have heard it before that broken clocks are at least correct twice a day, right? Because it hits that spot twice. That comes up to my next one. Sometimes you could also look at this scenario. You could go full circle around and stop at that spot. And of course, vice versa. You go a few times. So I'm using it overlapping, but you get the idea. So the idea is we could also go a full-time circle around. If that's the case, guys, when you're doing a full circle around, you're actually adding, well, how many degrees is it completely around a circle? 360. So we could say plus 360, and that'll give us, tell me what the angle is and add 360 to it. You found a coterminal angle. Very simple. If I have 30 degrees as my angle, add 360 and get 390, that's a coterminal. They both start and end at the same spot. Ignore the fact that it goes completely around once. It still starts and stops at the end. They're still ending at the same spot. Right? 30 degrees, add 360 gives you 390 degrees. Subtract 360. If I go in the negative direction, gives me the same thing. I go the opposite direction and get the same result. So if I take 30 degrees and subtract 360 and get negative 330, negative 330 gives us to the same spot as positive 30 does. We'll get to some examples in a second, guys. All right? So let's go and dive into some of these here. So let's draw in standard position 160 degrees. So we have our x and y. We're going to start here, and we're going to go 160 degrees. So we go over here. It's going to be above 90. Bless you. It's above 90. Is it above 180? No. So we're going to stop into the second quadrant. And that gives us 160 degrees. And he goes on to ask, and again, one more time, let me write this somewhere for you guys so you can keep it as a reference if you haven't seen it already. First quadrant, second quadrant, third quadrant, fourth quadrant. So it starts with the upper right and goes counterclockwise. It follows the positive angles path. Counterclockwise, which follows a positive angles path. So if we're looking at this 160 degrees, what quadrant is it in, guys? Second. Yes. 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 That's the way you identify quadrants, by using Roman numerals. Then it goes on to ask, what is our reference angle? Well, the angle is 160. What quadrant are we in, guys? We are in the second quadrant. So do we need to go down to the x-axis or up to the x-axis? Down. How many degrees does it take to get me to the x-axis? Well, it's 180 degrees, isn't it? Minus 160, because that's the distance I'm looking for. So the reference angle is 20 degrees. Let me show you what reference angles is about as well. So, you have your calculators, right? Make sure it's in degree mode, please. I want you guys to go ahead and find the sine, cosine, and tangent of 30 degrees. You group, okay? 30 degrees. Write it down somewhere. Sine, cosine, and tangent of 30 degrees. So that's 30 degrees. What's y'all's reference angle, guys, if it's 30 degrees? What's your reference angle? We're in the first quadrant. We're going up 30 degrees. How many degrees does it take me to get back to the x-axis? 30 degrees. Y'all's reference angle is 30 degrees. Got it? You guys over here, you're going to do 150 degrees. Sine, cosine, and tangent of 150 degrees. Think about it. 150 degrees starts, for you guys, it's here. Nope, here. And you're going around, and you're over here. So what's the reference angle for that? 150 degrees. 30. Same reference angle, right? Go ahead. You group here, not you two. You two are up here. You two right here. I want y'all to do the sine, cosine, and tangent of 210 degrees. Okay, 210. Because you guys will be going from here around to 180, and then 210 means how many more degrees did y'all go? 30. So your reference angle is 30 as well. So do sine, cosine, and tangent of 30. And you guys are going to go ahead and do 330 degrees. Sine, cosine, and tangent of 330 degrees. You guys have 210. 210. I want you to put in the 210. You guys got 330. Let me show you the method to all my madness here, guys. So let's look. Well, I'm going to need more space here. All right. So if you look at 45 degrees, what quadrant are you going to be in, guys? First quadrant. So weird. Okay. So you have 45 degrees. What is our reference angle? 45. You said we're in the first quadrant. That is correct. And that's it. So draw where it is. Actually, I should probably use a different color so it stands out a little bit. There you go. 45 degrees is there. Negative 60. Now, guys, it's important for you to draw the arrow that I'm doing there because it shows you the path of how you got there. So we have our standard position. So we start here. Then we go negative 60 degrees. What would be the reference angle here, guys? 60. What quadrant are we in? Fourth. All right, last one. 405. What is that? What do we know one thing about 405 degrees? It's a full circle, so we're definitely going to start here. It's positive, so we're going to go counterclockwise. How much more do I need to go after that? 45. Good. So, what you could say is this, that 405 and 45 degrees are coterminal angles. 405 and 45 degrees are coterminal because they both end in the same spot. So, going here now to look at what is our reference angle? 45 degrees. .405 took us into what quadrant, guys? First. All right. So this is what I was telling you guys. Is we always talk about degrees. You've always been talking about degrees in geometry. You may have dabbled into a little bit of radians, but now we're going to go ahead and really dive into both of them. And the idea is to go converting from one to the other. Okay. So to convert each angle, says there are two ways to measure angles, and you must be able to convert between them. What I always like to say is if you're given an angle, so whatever that might be, basically, if you guys knew it in chemistry, I know some of y'all don't even like to reference that, but the idea looks like this. You put how many, what's revolution? One revolution around the circle is how many degrees, guys? 360. So we come over here, we put 360 down below, because they'll cancel out. Oops. And you put pi there. No, sorry guys, pi is there. This needs to be 180. The revolutions threw me off. I'm sorry, it should be 180 degrees. If it's one revolution around is 2 pi, which is 360 degrees, what do you think halfway through is? What's halfway through a circle? 180. So we'll say 180 degrees is equal to pi rads, or 1 radian. So you can use that to help you out. So if you're going from degrees to radians, that's what it should be set up like. You set whatever the question is, you divide it by 180, and multiply it times pi. If you're going the opposite, if you're going from radians to degrees, then you take whatever radian it is, and you flip the conversion. If you notice 180 is on bottom here because that represents degrees. And if you remember back in the days of chemistry, stoichiometry, or dimensional analysis, whatever y'all called it, you want the opposites, you want the sames to be countered from each other so they cancel out. Same as here, the pi is going to cancel out and you're left with that 180 there. Okay? So let's see what that looks like. So we have 60 degrees, we've got to convert it to radians. So we say, okay, it's going to be pi over 180, because the 180 needs to be on bottom. Well, can 60 go into 180? How many times? 3. That goes away, and that's left with 3. And so pi over 3 is what you got. And you went from 60 degrees is now pi over 3 radians. And that's the same process. So 150 and of course, guys, you are going to have the calculator with you during this. So if you need to, you can always put 150 alpha y equals 150 over 180. Press enter, and it'll give you the reduced fraction. But do we know a greatest common factor that goes into 150 and 180? 30? 3? 30, actually 30 is right. Because those go away. And so you're left with, well, how many times can 30 or 3 go into, how many times can 30 go into 150? Good. How many times can 30 go into 180? 6. So you get 5 pi over 6. The other idea is you put in your calculator 150 over 180. If you press enter, you get 5/6. You got to make sure to put the pi in there, though. Okay? The pi will always go on top. All right, negative 45 degrees. Well, you already know in radians it's going to be negative. If the degrees is negative, the radians is negative, okay? And 45 can go into 180. Does anybody know how many times? That's right, Andy. 4 times. And there you go. Yes?
But in the original analysis, all we did was, like, we would take the 45 multiplied by pi and then divide by 180.
Right. But what I'm doing is I'm kind of converting, I'm putting math and chemistry together. And the fact, if you know about fractions, you could always cross-cancel or cross-reduce.
So it's like, if you were to multiply.
If you were to multiply times, well, here's the deal. In your calculator, you can't put 45 times pi. Because the answer needs to be in terms of pi. So pi actually goes away. You put in your calculator 45 divided by 180 and press enter. And make it a fraction. And then put pi back in. So in your calculator, guys, do this. Do alpha y equals, please. In your calculator, put alpha y equals 45 over 180 and press enter.
You get 4.
Did you do alpha y equals?
No.
You got to do alpha y equals. 1/4. 1/4 is what you get. If you do alpha y equals, the calculator gives you as a fraction. And you could always do math, enter, but that's just another step. If you saw that, you put it in, you got 1/4. Well, 1/4 is 45 over 180. However, we still have that still there on top, so put it back in to write your answer. So 1/4 ends up being 1 times pi over 4. Well, the 1 goes away, doesn't it? It's just pi over 4, and that's what happens. So, do what? A negative. Yeah, negative. Follow the negative sign as well. It's easier sometimes to see here because there's no 1. If you were to put 150 over 180 in your calculator, you'd end up with 5/6. Go back, put a pi on top, and you're done. Same thing here. If you put 60 over 180, you'd end with 1/3. Put pi on top, and you're done. Okay? All right, that's converting from degrees to radians. Now let's go the other way around. You can use stoichiometry if you want on this one. I usually use the division sign as my horizontal line, as you can see there. And then we go ahead, cross cancel pi's, they go away. Can 6 go into 180?
Yes.
How many times? And there's your answer. Seven pi over 3. Same setup. It's always nice to cross cancel, guys. Now, granted, yes, you do have a calculator. And in your calculator, guys, what I would do, if I were you, is I'd do 7 times 180 divided by 3. But in this case, we can cross cancel. 3 can go into 180 60 times. And 60 times 7, 420. Same thing for the last one. It's negative 40 times. And you get a negative 120. So as you can see, guys, whatever the questions is and what version, make that on bottom of your fraction. So, all right, it's 60, so 180 is on bottom. Oh, it's pi, so 180 is on top. Or however, or pi's on bottom. However you want to think that, that's how you convert back and forth to those. Okay? I think you guys, and I've seen it, you guys are going to get this process down pretty well. It's going to be the math part of it. It's the canceling out, reducing. I see people kind of derail on that process. The setup looks right. It's just the breaking down and getting the answers where we kind of start slipping up on that one, okay? All right. We are going to, and I'm so glad we're doing this, do away with linear and angular speeds. Which means example 2 and the other example 2, example 3, 4 are all gone, and that ends for today.